In this video, we are going to calculate standard deviation and the coefficient of variation and the probability of reaching a value below zero. We're going to do it the more manual step-by-step way, and then we're going to talk about using array formulas in Excel to make it a little easier. So in this example, we have two projects, and these are the NPVs for project A, the potential NPV of project A, and the potential NPVs of project B. Now, each one of these outcomes has a different probability of happening. This NPV in the middle being the more likely at 40% probability, higher NPVs being a little less likely, and negative NPVs, lower or negative NPVs with those probabilities. Now, if you want to calculate the standard deviation of these NPVs in order to assess the risk of the project, then you can't just do the regular approach because these do not have the same probability of happening. They have different probabilities. Another way to interpret that is they have different weights. This one, since it has a 40% probability and the highest probability in the group, has the more weight to the potential outcome, to the expected outcome. So we have to do a weighted approach. So if we do a step-by-step approach, we're going to follow this table here. So first we need to find the expected NPV, which is the same as doing a weighted average when you have different probabilities. So here the formula, we're going to multiply each probability by its NPV. And then we're going to do the sum of that. We're going to add them together. So let's start with project A. So all we do is start with an equal sign, take the probability and multiply it by the NPV associated with that probability, or the probability associated with that NPV. Once we have that, we can just drag the formula down. And we have all the weighted NPVs according to the probability. And here at the end, we want to add them together. So we hit the auto sum. It's already guessing that this is what we want to add. So we can go ahead and click enter. And that gives us the expected NPV, which is in this case the same as a weighted average. Now I'm going to call this step B. There's a step in between that and the variance just to break it apart. We could do everything in one more step and go straight here, but I'd like to break it in steps to make it a little easier and to prevent potential errors in formula writing when you're in Excel. So what it's telling us here is to take each NPV minus the expected NPV we calculated here, and then we're going to square it. So I can go like this, start with a parenthesis. So each NPV minus the expected NPV, and I'm going to square it. Now I'm going to go here on the E8, which is the expected NPV, and I'm going to put those dollar signs around it so it locks it in place. That way, I can then just drag the formula down without having to retype them every time. And those are our results after we subtract those two and square them. Now, in order to get the variance now, we're going to take B, that's step B. In other words, each one of these, that's why I just wrote B there, times each probability again. Because now we got to weigh those in. And then we're going to add them together. That's why the sum sign is there. So we take the value from step B times the probability. And now we have that value. Now in this one, no need to lock anything. So we're gonna go ahead and drag them down. And here at the end, we're gonna add them together. We're gonna do the auto sum up here. It already guesses what we're looking for. And it gives us the variance. So here we have the expected NPV, which in this case is a weighted average. Now we have the variance. Now the standard deviation is as simple as the square root of the variance. Here we have it represented with an exponent of 1/2. And all we gotta do is take the square root of the variance. So we can use a square root function of Excel, SQRT, open parenthesis, select the variance, and that gives us the standard deviation. If we were to follow the actual formula as written, we can also do that. We take the variance and we raise it to the 1/2 power, and it gives us the same number. Now, that is a way to calculate the standard deviation in a step-by-step process for project A. If we want the coefficient of variation, we simply divide the standard deviation by the expected NPV. So we take the standard deviation divided by the expected NPV. And this gives us a coefficient of variation of 1.64. The higher this number, the higher the risk of the project. Okay. Now, what I want to know, what's the probability of this project, because it has some negatives and some positives, what's the probability of this project actually going negative on the NPV? Even if it's -1, just -$1, what's the probability of it going below 0? Or in this case, equal or below 0. But below 0 is a fair enough way to say it. So there is a function in Excel that uses the normal distribution, which is the bell curve. And the way we will use it here is we start the, let's actually do it through the, we start with typing in normal to find it. The one we want to use is normal S distribution, because we like to use sample. So we're gonna go with that. Now, once we have that, we got to open a few values here. So on the normal distribution bell curve, the middle point right in the middle, which is the average, that's considered a z-value of 0. A z-value of 0. And we want to know also what is the probability of it going below 0 in the negatives. So the way that Excel can interpret this is we're gonna open another parenthesis and put 0 minus that expected value, which is like an average. Let's close the parenthesis there. Divided by the standard deviation. Okay. So 0 meaning the NPV 0 minus expected value divided by the standard deviation, and that gives us a z-value. That way, the computer now knows, or Excel now knows, which position in the normal curve is going to be, and it's going to tell you the probability that it represents the area under the curve. So the next item, the one who is cumulative, will actually spot. So for the purposes of this, calculation, we go for cumulative. And as you know, it gives you options, true or false, as you can see here. Since we're going for cumulative, we write true there. And we're going to close the parenthesis. So that's what our formula will look like to properly use this. Now let's cross our fingers and see if it all works out. And yes, so there is a 27.14% probability that this project can end up in a negative. That is the probability that that project may end up in a negative. Now, the idea would be to then redo all these steps with project B and compare these items to see which one you prefer. Compare this item and these items. Now, as you can see, there was many steps in between and so on and so forth. Now, let's practice using array formulas, which will save us a lot of this work. So we can still get the same values, calculate the same values using an array formula in Excel. Now, notice it says there Control plus Shift plus Enter. When you do a regular formula, let's say you're going to do equals this plus this, then you just hit Enter and it does the formula, right? What we're saying here is that to do an array is after you enter the formula, instead of just hitting Enter, you need to hit Control Shift Enter. And let's see how that plays out. So let's say I'm going to do project A. I want to know the expected. So I'm going to start by the formula. Now, notice here that there's like a sum and then a probability multiplied by the NPV and so on and so forth. That is what we did here. Probability times NPV, and we added them together. All right, so we're going to do the same thing. We're going to write sum because we're going to add them together. But we're going to tell, okay, I want every one of these probabilities multiplied by every one of these NPVs. So what are we telling Excel? Multiply each probability times every NPV and then add them together. Now, if I do not do Control Shift Enter and I just hit Enter, I'm going to hit Enter only to demonstrate. We're going to get an error saying I can't calculate the value because just the way we wrote it, Excel doesn't understand that you're asking you to do one by one and then add it. However, if we go back in there, you're still going to type it that way. But all we're going to do now is we're going to do Control, Shift, and Enter. Now it gives us a value and you see it did it. It matches the value. What does it look like? If you look up here, notice how it puts some brackets on the side, identifying that it is now an array formula. Now, let's say I go back in there. It doesn't show the brackets. It just shows the formula. And if I hit Enter by itself, it goes back to value. So if you go back in there to modify the formula, you have to again hit Control Shift, Enter. And as you see the brackets here, you see the brackets there. Well, the brackets disappeared because I entered it. If you see the brackets there, identifying that it's an array. If we go here and hit Show Formula, it's still only going to show you the formula without the array. So that's how you do an array formula, and it saves you these steps. So you can do the same with these other ones as well. Okay, so let's do the variance, for example. So the variance is calling for the sum of this calculation times the probability. So we got to kind of write a combination of these two calculations. Okay, so let's start with equal. There's a sum involved. This is for variance because that's sum there. Of. So we need the probabilities. The probability is part of the formula. Okay, we're going to multiply that by each one of these NPVs. Now remember here, we took the NPV minus the expected NPV, which we already have here. So I'm going to put a minus this, minus expected NPV. And remember, we also have to put a square there. So we are going to put a square. And we're going to close everything up. So to review, this is the sum of each probability times each NPV that has been reduced by the average NPV or the expected NPV, and then it gets squared. So this piece here is combining these two. Let me rephrase. This piece here is this piece here. Then is being multiplied by the probability part. So we kind of flipped it, but it could have been another way around too. But it's combining these two steps, and then it's going to add them together, the sum. Now remember, Control-Shift-Enter to let it know it's an array. And as you see, we have the same number without having to go through all these steps in between. Okay. Now let's start deviation. We can do the square root of the variance. We still get the same number. Coefficient of variation is the variance divided by expected NPV. And let's review the normal S distribution. I'm going to do 0 minus the expected because we want to know about being negative, divided by the standard deviation. So it gives us the Z value that we're looking for. And because it's cumulative probability, in order to capture the entire shaded area under the curve, and there's our 27.14%. Now, all we do is we do the same thing for NPV, the B project. So I can do a small adjustment. What I'm going to do is I'm going to lock in the probability in each place. So I can, Control-Shift-Enter, always remember that. But now that I locked in the probability cells, I can just drag the formula. So in this case, both projects do have the same expected NPV, but let's see if they have the same variance. In this case, I'm also going to lock in the probabilities. And let's do that again, so as an array. And that is our variance. Look at the formulas doing the probability and the PVB and the expected NPV of project B. And that is our variance for that one. Now we can already tell that this variance is higher than this one. I'm sorry, the variance it is lower, but when we do the square root, you might have a different outcome, but let's see if it's true. So let me say it again in a different way. The variance, you can already see is lower than this one, which already suggests a lower risk. But the standard deviation is the one that we should always use for these decisions. So since this was not an array, I can just do that. And that's the standard deviation, a lower standard deviation, which should result in a lower coefficient of variation. And it does. Now for the probability, you should be able to just drag it, and we do have a lower probability of being negative. So both have a potential of being negative, but the probability of this one being negative is much lower. So here's the deal. They both have the same expected net present value, but you still have to decide between these projects. So by looking at the standard deviation, it already clearly tells you that project B has less risk. The coefficient of variation is telling you it's less risky. The probability of it being negative is much lower, almost half. So the decision should be that if I'm going to get the same net present value, then do it for the lower risk. If the expected net present value is the same, then you do it for the lower risk. The lower standard deviation in this case is the easy way to decide between these two once you hit there, because these are the same. Now, if these two expected NPVs were different, that's when you use the coefficient of variation to decide. The lower coefficient of variation is the more efficient project when it comes to risk-adjusted returns, or what you're getting in value per unit of risk. And it would also reflect here, there's additional information that is useful for risk assessment, that the probability of going below zero, in other words, a negative value, it's much lower. So the decision should be here, project B, based on risk versus value. So we will stop this video here and continue talking about risk on the next video.